So now we are looking at infinite series. An infinite series is of the form, all right, and this is on page 3 of your series packet. So for your series notes, this would be on the 3rd page of your series notes.
Okay. Just keep
All right.
going.
We can't finish part one.
Well, part 1's
We should put it in this episode.
already up there, so I want to continue where we left off on the previous part.
Well,
Yeah. Okay. All right. Well, looking at the notation, what this is saying is if you start at when n equals 1, remember that's our index value, and that's where we start at. So that's the index. It's the term that we start with. Term to start with. Then you have your stopping number, okay? So this is the term that you stop with. So this is the term to stop with. So that means that you start at the first term and you end at the infinite term. So this means the sigma notation with your stopping number index at n equals 1, your stopping value at infinity of the term sequence an means you add the first term, the second term, the third term, all the way up to the infinite term. So you add an infinite amount of terms following the pattern. All right? A couple of notation points. So if you have an infinite series where your stopping number is 1 and your index is 1, your stopping number is infinity, of let's say just any term an, then the limit as n approaches infinity of the series where k is equal to 1 for the number of terms in the series. We're on page 3 with infinite series, and we're just making a note about notation. We're going to apply it next time in the example problems of an. All right, that's going to be equal to the series. So what all this is saying is that the limit for the function in that you're taking the series of, the limit as n approaches infinity of the series, that's what the series is going to be equal to. So that's just getting the notation down. So yeah, so remember, a series is just adding up the terms in the sequences. So a series is adding up the terms in the sequences. All right.
Wow. Hey, you know this is a crazy thing. You see the button on the side? This button right here? Right? Bam.
Oh my god. I've never seen this.
Nice.
All right. Let's clear your annotations. Unless we're getting stuff. Are we still getting it down? All right. So let's looking at the limits of partial sums. So now we have a series. For each of the following series, find the first 5 terms in the sequence of partial sums. Which of the series appear to converge? All right. So let's look at the pattern here.
So, Mr. Wong,
Yes.
the pattern
Let him
Yes.
do the note.
The pattern
He's
is
the teacher,
multiplying
not
by
him.
0.1, right?
Well, let's see. We have. Let's do 0.1 plus 0.01. All right. So that's going to be. So if we add the first term, we just have 0.1. If we add the first two terms, we will have 0.11. All right. We add the first three terms, we will have 0.111. That's the first term. 0.1 is the first term. 0.11 would be the second term if we added the first two terms. If we had the first three terms, that would give us 0.111. If you added the first four terms, right? 0.1 plus 0.01 plus 0.001 plus 0.0001 would be 0.1111. All right? And so with this series, it appears to approach 0.111 with 1 going on forever. So this appears to approach 0.1, and you're going to have a bar over that 1, and that bar means that 1 repeats forever. All right? Now, 0.11111 going on forever. How would you use your calculator to try to convert that into a fraction? So that should be 1/9. If you're all right, so what you can do is take your calculator, use 0.11111, add a whole bunch of ones there, right? And then you hit the math button, go to frac, and that's going to convert a decimal to a fraction, math frac, and that will give us 1/9.
Well, you press math.
So I put 0.11111, put a whole bunch of ones,
Okay.
hit the math button, hit the frac button.
One,
The frac, so I hit math, then I hit frac.
is that one? Number one?
Yeah, it should be math frac. That should be the first one.
Okay.
And that function will convert any decimals into a fraction. That should spit out 1/9.
It just put 1.
Well, if you did 0.11111, do a whole bunch of ones like I did, and convert that into a fraction, that should spit out 1/9. So if you do the exact same functions I did in my calculator, yours should spit out 1/9. That's going to approach 1/9. So that means the series converges. All right? So I want you to notice something here. And this is an infinite series, which means that even though you're adding an infinite amount of terms, the sum of adding these infinite number of values isn't infinity. It's possible that your terms are going to add to a value that isn't infinity. Restroom, yes. All right. Okay, so let's look at B. With B, it looks like you have the first term would be 10. 10 plus 20 would be 30. 10 plus 20 plus 30 would be 30 plus 30, which is 60. 10 plus 20 plus 30 plus 40 would be 100. The next term, by the way, would be 50, so the next term would be 150. Notice we have plus 20, plus 30, plus 40, plus 50. And so it looks like, but it looks like the sum increases without bound. Because it increases without bound, the series is going to diverge. All right. So the series diverges because we do not approach a limit. All right, so that's B. All right, and for C, even though there's not too much space, I can fit it all because if we notice the pattern here, when the first term would be 1, then you add the first 2 terms, you would get 0. Add the first 3 terms, you would get 1. Add the first 4 terms, you would get 0. Add the first 5 terms, you get 1. And notice we're not really converging to a value here. Okay? What's happening here is that these numbers oscillate. The numbers oscillate. O-S-C-I-L-A-T-E. They oscillate and they do not approach a limit. All right, so that's what oscillating means. They move back and forth between values and don't approach a specific value. Do not approach a limit. Because of that, the series diverges. The series diverges with no sum. So the series diverges and it has no sum. All right. Because the series diverges because it's not going to have a specific sum when you add it infinitely. Because the series of this sequence, odd values are 1. Even values are 0. If you were to take an infinite series of the sequence, infinity is neither odd or even, so you couldn't really specifically tell what the whole thing would add up to. All right. Let's, does anybody have any questions? Am I good to clear here? Or do people need to write down more? Do you have questions? All right, let's focus here. These aren't the easiest concepts to grasp. All right. Am I good to clear?
Yeah.
All right. All right. Once again, let's refocus here. If you're off task, let's get back on task. So a geometric series converges if and only if the absolute value of r is less than 1. If it does converge, then Sn is equal to a over 1 minus r. So what this is saying, putting this in English, is that if you have a geometric series, it's only going to converge if your common ratio is less than 1. Because think about it, if your common ratio is greater than 1, then eventually your series is going to diverge as it gets bigger and bigger and bigger. But if it's less than 1, you can converge to a bad value. Sn is equal to a over 1 minus r. Remember, a is your initial value, and 1 minus r is 1 minus your common ratio. Okay, so that's just formulas, so no notes taken down there. Let's do example 4. All right, determine whether the series converges, and if it converges, give the sum. All right, so first of all, any series, right, is going to be in the form a1 times r to the n minus 1. That, and remember, that variable could change. For example, this time the variable is k. All right, so in this case, r is equal to 0. So 3 is a1, 0.75 is r, all right? And this is to the n minus 1. So r is equal to 0.75, right? And the absolute value of 0.75 is less than 1, so this converges. And because it converges, we need to figure out what it converges to. We need to find the sum. So this sum is going to be, let's find out. Sn is equal to a1 over 1 minus r. Remember, a1 here is 3, r is equal to 0.75. So the series is equal to 3 over 1 minus 0.75, which is equal to 3 over 0.25. All right, and 3 divided by 0.25 is the same thing as 3 divided by 1/4. And 3 divided by the 1/4 is the same thing as 3 times 4. And what's 3 times 4? 12. So the series, the infinite series, is going to be equal to 12. So S is equal to 12. All right, let's look at B. All right, here, it's going to converge because negative 4/5 is less than 1. The absolute value of negative 4/5 is less than 1, so it converges. And remember, this is for a geometric series. All right. So in that case, A1 is going to be equal to 1 because A1 would be equal to negative 4/5, and their starting value is 0. So if our index value is 0, then A1 would be, the first term would be when n is equal to 0. So that's our starting value. So A1 is negative 4/5 to the 0. Anything to the 0 power is 1, which means A1 is equal to 1. So always look at your index, which is the value that you start with. Your first term is going to be plugging in your index into your series equation. So when you plug in 0 into negative 4/5 to the 0 power, you know that negative 4/5 to the 0 is the first term. So our first term is 1. All right? And so now we've solved for A1. So now we just need to find Sn. Our series, Sn, is equal to A1 over 1 minus r. Which means our series is going to be equal to 1 divided by 1 minus negative 4/5. Which means it's going to be, the series is going to be equal to 1 over 1 minus negative 4/5 is 1 plus 4/5, which is going to be 5/5 plus 4/5, which is 9/5. And 1 over 9/5 is going to be equal to 5/9. So this series will converge to 5/9. All right. So that's example 4. At this point, I want you to please ask questions.
How did it?
It was fine, but please ask relevant questions based on the mathematical topic at hand. Yes, David?
I need to get B now.
Okay.
Finish.
All right. So let's gonna clear. Am I good to clear annotations? All right. Sum of an infinite geometric series. All right, so let's check this out. 9/10, the absolute value of 9/10 is less than 1, so it converges. All right, furthermore, A0, remember our starting value is 0. So A1 is going to be equal to 9/10 to the 0, which is going to be 1. And then let's find our series value, okay? Sn is equal to A1 over 1 minus R, which means it's going to be equal to 1 over 1 minus 9/10, which means it's going to be equal to 1 over 1 minus 1, 9/10 is 1/10, so 1 divided by 1/10. So 1 divided by 1/10 means that the series is going to be equal to 10. All right. B is pretty simple. Pi over 2, which is equal to R, is the absolute value of pi over 2 is greater than or equal to 1. Because greater than or equal to 1, the series diverges. All right. Any questions thus far? Please, if you have questions, I want you to ask them to clear up. Because pi, remember, pi is about 3.14. 3.14 divided by 2 is still going to be bigger than 1.
So we just leave it like that? Like 1 over?
1 over where?
It will be like 1 over 1 minus pi over 2.
So that's just I'm just saying R is equal to pi over 2.
Oh.
That's that's your common ratio. Because when we see, because that's what we're raising to the power. So if you don't have a coefficient for your common ratio, that means your starting term is 1. Am I good to clear annotations, or do you guys need more time to write down?
We're good. 8 minutos.
Otro minuto.
All right. Receipt. All right. So here, if we notice, each term is going to be multiplied by 1/2. All right. So R, 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. So we know that R is equal to 1/2. Absolute value of 1/2 is less than 1, so the series converges. Our starting value is
1.
A1 is equal to 1. So our Sn, our series, is going to be equal to 1 over 1 minus 1/2, which is going to be equal to 1 over 1 minus 1/2 is 1/2. So 1 divided by 1/2 is equal to 2. Yes. Yes. Diverges. So our R value, the rate of change between each term in the sequence. So for a geometric sequence, when notice each term in the sequence is given by multiplying the previous term. So 1/2 is given by multiplying 1/2 by 1. 1/4 is gotten by multiplying 1/2 by 1/2. 1/8 is gotten by multiplying 1/4 by 1/2. So this is a geometric sequence because each term in the sequence is the previous term times 1/2. And for a geometric sequence, if you add all of the terms in the geometric sequence, if your R value, which is the value that you multiply for each term, is less than 1, then it will converge. And what will it converge to? It will converge to A1 over 1 minus R. But only if R is absolute value of R is less than 1. And R, remember, R is just what you multiply to get to the next term in the sequence. All right. So, am I good to clear? All right, I'm going to clear. For the last page, I want you to look at me working through it and see if it makes sense. So, putting this in fraction form, all right, we can say that the first term, right, is 0.234.
Yeah.
All right. Our R value is going to be 0.001. All right. So think about it. Each give this in fraction form. So because of that, you could do S is equal to 0.234 over 1 minus 0.001, which would be equal to 0.234 divided by 0.999, which would be equal to 234 over 999,
Yeah.
which could simplify into 26 over 11, or 26 over 111.
I like the diligence.
All right. So one last step is I want you to think about .234 plus 0.0002 234 plus 0.000000234, and so on and so forth.
Yes, that's what it works.
And what's this for?
That's for coming up with your R value. All right, that's your video, and have a great day.
Oh my God!